Configuring networking in a vSphere environment really isn't all that hard a task to accomplish, but configuring it well, or in some cases even configuring it correctly, can be an altogether different matter. There are a lot of different things you have to set up, and in many cases, you can set certain configurations in ways that you might not even notice that they're incorrect until, well, it's a bit too late. Also, vSphere is one of those sort of rare IT technologies that tends to bridge across the traditional IT silos. You as a virtual admin are going to be asked to also be a bit of a network admin. You're also going to be asked to be a bit of a storage admin as well. And so there are technologies and approaches and best practices that you kind of have to learn and implement that would normally be part of the job of somebody else. Well, here in this nugget, we're going to spend some time talking about just some of the most basic of networking implementations that you can do with vSphere today, using the vSphere standard switch. A vSphere standard switch is very much like a regular physical switch in that it's designed to route traffic between machines, in our case is virtual machines, and also via uplink ports to route traffic to other locations on the network as well. You will be configuring a variety of port groups. You'll be configuring policies for those port groups. You'll be associating VLANs with those port groups in certain circumstances as well, so that your virtual machines can talk to each other and talk to the other equipment that exists in your data center and out throughout the rest of your network. So very much like your networking team, you're going to have to know some networking concepts in order to be successful, even with vSphere standard switches. Now, the standard switch is one of two different types of switches that exists right out of the box whenever you implement vSphere. The other type of switch is a distributed switch. And we really can't at this point talk about many of the detailed use cases for why you would choose one over the other, but I can talk about one. And that has to do with which version of vSphere you actually purchased. In order to make use of the distributed switch, well, you have to have the Enterprise Plus version of vSphere. Without that, well, you're going to be using standard switches for pretty much everything. In this nugget, we're going to spend some time creating really a couple of different standard switches. And then once they're created, we're going to configure some of the NICs, some of the physical NICs associated with them, also some VM kernel ports for a variety of network services, and a few port groups as well, so that our virtual machines will ultimately be able to connect with the rest of our network infrastructure. But before we get into the click-by-click, I want to spend some time just kind of talking about the different categories, the general types of network traffic that you're going to need to prepare for as you go through the design of your virtual network infrastructure. I'm not so interested in talking about the individual ports or even the protocols associated with those ports, but just generally the kinds of traffic that you have to think about that gets pulled into each individual ESXi host. We have to talk about this here because, well, when we create our standard switch, we need to create it or them in ways that facilitate appropriately how that traffic gets routed around. I don't want an overactive storage connection to impact my production networking traffic. I don't want the fact that I'm vMotioning to take away resources from some other need for virtual machines. So let's talk for a minute about the different kinds of traffic that you might plug into an ESXi host. First and foremost is just simply your production networking traffic. For me, production networking traffic kind of corresponds to usually the IP addressing, the subnet that you set up in your server room now, your server net. Right, if you have an Exchange server that needs to talk to Outlook clients and vice versa, those clients are going to talk over a production networking connection into your server net. That same production connection is where individual virtual machines talk to each other. So if an Exchange server needs to talk to an antivirus server, it's going to do so over a production network connection. I bring this up because this is an important differentiator from the other kinds of network traffic that we have to deal with in the virtual world. A best practice these days is not actually to have our virtual machines housed on local storage, but instead to house them on some sort of remote, sometimes IP-based storage. And so having a separate, at least understanding of your storage connections is no less important than your production networking. If you lose your production networking, your servers are offline. But if you lose their storage connection, your servers don't even really exist. So we have to think about storage almost as being separate from production as we start incorporating these things into the VMware environment. Now, because we're dealing with virtualization, we have a couple of other very important types of networking as well. One of which I'll just think about as management. In the virtual world, when I create a virtual machine, when I set up an ESXi host, the ways in which I go about enacting change on that virtual machine, powering it on, powering it off, snapshotting it, changing its configuration, is not something that happens via a physical set of buttons. I don't punch a button in a virtual machine to power it on. No, I have to send it a command over the network. Well, it's generally a good idea for me to segregate out that kind of command, the allowable space where those commands can actually be executed, from my production networking. Now, in addition to the management connection, we have some other connections as well. We got a vMotion connection. Now, vMotion, you can kind of consider it as being a kind of management activity, but vMotion, very different from your management commands, tends to at least have a very large amount of resources that need to happen during the period of a vMotion. When it comes time to vMotion a machine from one location to the other, you want that to happen as quickly as possible. And so we tend to separate out vMotion traffic for no other reason so that it doesn't impact the available resources for existing management connections, production, or for storage. These are kind of the core four. There are some additional ones too that we have here with recent versions. One is for fault tolerance connections. There is a way that we can set up virtual machines so that they're existing in lockstep. We'll talk more about VMware fault tolerance in an upcoming nugget, but separating that out into its own sort of category of networking is important. Also, we can separate out for virtual SAN traffic as well. Now, virtual SAN is a new technology in recent versions. Separating that out, even from individual storage connections, can be something that we may want to do as well. Now, I bring all this up because it helps you when it comes time to go through the design activities for your virtual environment. You might realize, well, wait a minute, if I'm going to create a production networking connection, it's probably a good idea for me to have a pair of network cards that are associated with production networking. Right? Bonded together so that if I lose one of those network cards, that I don't end up losing my services for my virtual machines. The same can hold true down here under storage. Well, I probably want to have more than one storage connection because if I lose that storage connection, just like with production networking, I've lost the VM. That can hold true in other locations too. Replicating the management connection can be important. Obviously, virtual SAN connections can be important. Additional vMotion connections are also important when it comes time to making sure I have load balancing and plenty of throughput for those vMotion activities. So again, just something to think about here when it comes time to design your networking infrastructure before you ever start clicking around in the interface. Let's spend a minute now kind of talking through how we go about configuring some of these items inside of vCenter. You'll see here that I'm on that server VC. We're taking a look at the vSphere web client here. And really, there's not a lot of differences between what you see here and what we ended up with at the end of that last nugget. Only one major difference here is that in the time between then and now, I actually added a couple more additional network cards to our ESX1 virtual machine so that I can show you the separation of some of this traffic. But other than that, what you're looking at here is pretty much as close to out of the box as you can get. So we are here again in the vSphere web client. I'm looking at esx1.company.pri. I am under the manage node here and then under networking, and I'm taking a look at virtual switches. Now I'm showing you here first because this virtual switches tab is it's really kind of the meat and potatoes of where everything gets configured as far as networking and the standard switches is concerned. And everything really starts here from this nifty little gray box that we see right here in the middle. I must admit that VMware has done an excellent job of creating a nice, easy to understand visualization for how networking works here with these standard switches. The gray box represents the switch itself, and I can apply configurations to that switch itself by clicking the little edit button up here. To the right and to the left of that gray box is where we begin to configure the different connections that occur in the virtual and the logical space. Over here on the right, you can kind of consider this to be everything in the physical world. Over here on the right is where you'll see your physical adapters. We only have one plugged in here at this point, but we'll be adding more here in just a minute. On the left side of the gray box is all the virtual space stuff. Under the virtual space stuff is where we will have things like VM kernel ports and VM networks which virtual machines will use for connecting up to outside resources. So virtual on the left, physical on the right, and it's within each of these different items that we end up making our configurations. I want to start by showing you some of the items that exist on the switch itself. So if I click here on the switch and then I click the little edit button here, we can take a look at the configurations that exist for that switch. Now, one of the first things you'll see here is we have a number of ports equal to elastic, and really no way to change this. In previous versions of vSphere, there was a need to actually set what the number of ports on a virtual switch would be, more or less at the time you created it. And there was a lot of best practices for how many you would create and making sure that you aligned it to the number of ports you needed. Well, in this version, in 5.5, VMware has kind of taken that configuration control away from us and just said we're going to deal with creating enough ports that are necessary for what your needs are. Essentially, they've removed a configuration from our need to control, which is great. We also have the ability to adjust the message transaction unit, the MTU. It is here where, for example, if you want to implement jumbo frames, you can change the MTU to the appropriate jumbo frames size, or if you've got other MTU requirements because of higher level networking, then you can accomplish that here by setting what this MTU will be. For the most of us, we're going to leave this MTU value to just what it is because that's the default value for now. When I create a vSwitch, I have the ability also to adjust some of the feature sets that are available on that vSwitch. So on this vSwitch, I can adjust whether or not I'm going to turn on promiscuous mode. Now, promiscuous mode is commonly used by network sniffers. So if I want to be able to capture the traffic and replay it back via some NetFlow or other utility, I'm going to need to turn on promiscuous mode so that I'll actually be allowed to capture that traffic. MAC address changes and forward transmits, although here are accepted by default, are commonly used by technologies like load balancers, so that they can say, you know what, I may actually be this MAC address, but in fact I'm this MAC address that I expose to the rest of the world. These are the default settings here, reject and accept, so I'm going to leave them the way they are, at least for now. Traffic shaping is one tool that you can use to kind of just keep an eye on what the traffic is going to be and to manage that traffic to a certain level. Now, traffic shaping is by default disabled, but you can, once you enable it, set what your average bandwidth and your peak bandwidth as well as your burst size should be for the traffic going in and out of this switch. Recommendation is to just leave this disabled unless it's an absolute necessity. There are other ways in which you can implement traffic shaping, either at the client level or deeper into the network, that are perhaps better than what you would accomplish here. So this is fairly limited in what it can accomplish. Where you will be spending most of your time is here in the teaming and failover sort of area. A lot of settings here. And different settings can have different impacts on how failover and load balancing may or may not occur with the different NICs that you've applied to this vSwitch. The first one here is load balancing, and you'll notice that there are 4 different load balancing policies that are available out of the box for how the traffic gets moved around the network. If I have multiple network cards, well, then I need to identify one of these load balancing policies to determine how the traffic moves between the different cards that I've associated with this vSwitch. Now, a couple of important considerations here that you have to pay attention to are specifically this one here marked route based on IP hash, and then the other one down here called use explicit failover. This top element up here, route based on IP hash, requires you to have some additional configurations at the physical network side or the upstream network side for the IP hash routing to work. Typically, this is Ether channel, 802.3 AD. Some people call it LACP, although LACP is a feature that's available in the distributed switch and not the standard switch. If you have Ether channel and you plan on using Ether channel can be an excellent way for doing some really good load balancing across the different NICs that you associate with this vSwitch. If you don't have Ether channel, or your network team doesn't want to provide it for you, or you don't have the kinds of networking equipment that can support that, either the route based on source MAC hash or originating virtual port allows you to incorporate high availability, but without the need for those advanced technologies that exist in the network infrastructure. So here in this infrastructure, I don't have a bunch of Cisco equipment that I can turn on Ether channel for, so I'm going to set this to its default setting of route based on originating virtual port. Down here at the bottom, the explicit failover order, what this is it gives you the ability to set one active adapter and then multiple failover adapters that only come into play when the active adapter fails. So let's actually set this so that I can load balance across multiple different NICs, although I'll have to add the NICs here in just a minute. I can identify here down with the second one whether or what technology is used to let me know if there actually is a network failure. Now, the default setting here is link status. When the link drops, we know that there's a network failure. Sometimes there can be a network failure that doesn't automatically create a link status droppage. For that, we use beacon probing. Beacon probing uses a variety of protocols of some very deep network foo to send communication around through the network to identify where the outage actually occurs. Tends to work best if you have 3 or more NICs that are associated with the vSwitch. And also, beacon probing will not work if you turn on Ether channel with the route based on IP hash load balancing policy here. Notify switches, tend to set this to yes, because notify switches indicates that when we have any kind of movement or change that is going on with the resources on this vSwitch, we want to notify the upstream switches so that they can adjust their routing tables, their ARP tables, and whatnot. The last one down here is failback, and this has most to do whenever we have unused or standby adapters, specifically standby adapters. Failback says that when the primary adapter comes back online, let's just fail all the traffic back to that primary adapter. Now again, I don't have Ether channel in this environment, so I'm going to set this up to route based on originating virtual port so that each virtual port will go through a specific NIC every time. And then with this, configure an additional network card to support that failover need. I'll click OK here to set this configuration the way we want. What we have to do at this point now is add in that additional network card. Let's go here and add that network card by clicking the little plus sign here. Here you'll see I can add a physical network adapter. I can add this physical network adapter to the vSwitch 0 switch that we have. It's the only one we have here at this point. I'm going to assign VMNIC 1. You'll notice that I have 4 of the total 5 NICs that are available here. VMNIC 1 gets added here in the list of active adapters. I choose Next, I choose Finish, and bam! We have now accomplished high availability for the port groups that exist here on the left side of this vSwitch. Pretty easy stuff. Well, when we make this configuration, setting up this high availability can be great, but we may actually want to segregate out some of the traffic for different purposes. Perhaps I want to set my VM kernel port over here, my management port, off into its own vSwitch, so that the management activities will not impact the actual production work of my virtual machines. Well, I can do that by first creating another vSwitch. Let's go ahead and do that now. I'm going to hit the plus sign here, and I'm going to add in another physical network adapter here. I'm going to choose Next, and I'm going to do that for a new standard switch. Now you might be wondering, well, wait a minute, why didn't I just go ahead and create a VM kernel network adapter for host management? Well, hold on a second. I want to maintain the existing VM kernel port group as opposed to creating a new one. So let's create that physical network adapter. We're going to do it to a new standard switch called vSwitch 1. I'm going to add in the proper network card, VMNIC2, choose Next here, and then Finish to create vSwitch 1. Now vSwitch 1 is fundamentally empty at this point. If I click over to it, you'll notice on the left-hand side, well, there's no associated port groups for this vSwitch. I have a physical adapter over here, but nothing over here on the left-hand side. Now at this point, I could create an additional VM kernel port for the purposes of this management traffic, but I'm not really interested in doing that at this time. What I'd prefer to do is this little button up here, to migrate an existing VM kernel network adapter over to the new switch. Let's do that now. I'll click here for the VM kernel adapter, choose Next. I'm going to give it a new network label. I'm going to call it Management as opposed to what it was before. Choose Next again. Looks like it won't cause any impact on network dependent services, so Next again and Finish. And after a second or two, we'll see that VM kernel port group will appear over here on the second vSwitch. Neat stuff, right? Neat ability here because I'm using logical software-based networking to really manipulate around how I want all these connections to occur. Another important configuration to be aware of are the differences between VM kernel ports and your VM port groups that you'll attach virtual machines into. Notice here how this VM kernel port has an IP address that's associated with it. If I want to connect up to this ESXi host, well, I have to connect up to a specific IP address, an endpoint as it were. Well, when I create over here a VM port group, here's my VM network, notice that there's no IP address associated with this. This VM port group exposes the rest of the network, or a specific VLAN in that network, to virtual machines inside of my ESXi hosts. And so it doesn't have its own IP address. This is an important differentiation because when you're working with your network teams to expose, well, to connect the rest of your network into your virtual environment, you're going to need to understand the difference between an access port and what we call a trunk port. An access port is just like the typical connections that you're used to dealing with when you plug a network cable into a server. An access port is an endpoint in your network infrastructure. So that access port will have a single IP address that it's associated with whenever you plug it in. A trunk port is a little bit different in that a trunk port is more like connecting multiple switches together. If you've ever had the joy of connecting switches together, you recognize that through typically that crossover cable, you plug one switch into the other, and neither of these switches have an IP address because neither of them is an endpoint. Be aware of this difference because when you're creating additional VM networks across different VLANs, it becomes important to tell your network teams that you're going to need trunk ports for those VLANs when you end up making those connections. The other reason why we want to talk about this is because once we have these switches in place, we have the ability to create multiple VM networks for multiple purposes. Think about your data center today. You probably have a server net, and it has a specific subnet, and that subnet has a VLAN associated with it. You might have another subnet and VLAN that's associated with your DMZ. Well, these can be separated here with this vSwitch by just simply creating another VM network. Let's start by actually adjusting the existing VM network that we have here. So here with this VM network, I'm going to click here and choose the Edit button. And let's assume that we're not in my flat network. We're actually in a VLAN network, or a network that includes VLANs. And my server net is in fact on the, I don't know, let's call it the 10 VLAN. So with this 10 VLAN, I can associate that 10 VLAN to this VM network. And we just know internally that the VLAN 10 is associated with the server net. When it comes time to add an additional network, perhaps for my DMZ, I can do so by simply click the plus sign here and adding an additional VM port group. Choose the next button, associate it with vSwitch 0, set up my connection settings, perhaps this is my DMZ network, change my VLAN here to the VLAN that's associated with that DMZ network, perhaps this is VLAN 11, choose next again and finish, and you'll see that we now have our original VM network, and added to it we now have our DMZ network as well. This gives us, just like with the logical separation, this gives us the ability to pull those VLANs directly into our virtual infrastructure. A little later on, when we start building virtual machines, we'll have the ability to associate those virtual machines to the appropriate networks based off of those that we've created here. Now, out of the 6 categories or major categories of network traffic that we talked about in the beginning of this nugget, there are 3 that we can kind of consider as special cases. Those are vMotion, fault tolerance, and virtual SAN. These are kind of VMware services that we can apply to a VM kernel port. I want to show you how you can turn on vMotion or enable vMotion on a separate VM kernel port so that later we can actually turn on vMotion once we build our first cluster here in our data center. Let me go back here to our vSwitch 1. Now this vSwitch 1, we're kind of think of it as our management vSwitch. We've created a management VM kernel port here, so it seems like an appropriate candidate for adding another VM kernel port for the purposes of vMotion. Let's go ahead and add that additional VM kernel port here. I'm going to go ahead and hit the plus sign again. And in this case, instead of creating a physical network adapter, I'm going to create just a VM kernel network adapter. You'll notice that VM kernel network adapters can be used for all kinds of things like vMotion and iSCSI and fault tolerance and FCOE and host management. Now, when I create a VM kernel network adapter, as I said before, we're going to have to also associate an IP address to this VM kernel network adapter. Where, in addition to that, we'll have to make sure that we turn on the correct services to limit it to just the services that we want for this particular port. I'm going to associate this with vSwitch 1, choose Next here, and then we're going to give this a network label of vMotion. The VLAN ID, we'll just set this to none for now. I can choose IPv4 or 6, and if I had alternative TCP/IP stacks, I could use them here, although we're going to just leave this as the default for now. I'm showing you this also because I want you to be aware of these available services here. It is these services that you'll want to segregate out appropriately onto whatever VM kernel ports and associate those with the vSwitches that exist in the environment. In my case, I just want vMotion traffic to occur over this single port group. This gives me the ability to migrate it around if I see the need to at some point later on. I'll choose Next. And for here, I need to either obtain IPv4 settings automatically, or I can use static IPv4 settings. So for this, I can just choose to obtain those IPv4 settings automatically to use my existing DHCP server on this subnet. I'll choose Next and Finish. And as you can see here now, we have a second VM kernel port that gets created here on our management vSwitch, one for the actual management, connecting up to it from our vCenter server and our vSphere client, and then a second that is specifically identified for use by vMotion. I think that's 5 of the 6. We still have a sixth of those classes of network traffic that we have to deal with, and that sixth is going to be storage. Now, storage traffic can occur, it will be a little bit different depending on the type of storage that you have. If you have fiber channel, you won't be using IP-based storage at all. If you have iSCSI or FCOE, fiber channel over Ethernet, then you'll need to create additional VM kernel ports that are associated to that IP-based storage. And I'll tell you, I'm going to punt just a little bit on the completion of this IP-based storage configuration because there's a couple of additional configurations that are perhaps best to be left in the storage nugget than are they here in this introductory networking nugget. So hold on for just a couple of nuggets and we'll talk about how to finish this configuration of networking when we start the configuration of storage. So with that, what have we talked about in this nugget? We have talked about some of the basic configuration of vSphere standard switches. We talked about just the fact that a vSphere standard switch is a lot like a physical switch. It allows your VMs to connect to each other. It allows your VMs to connect up to the outside world. It can be used for some specialized functions like vMotion and for management traffic and even for storage. You will probably be using standard switches unless you have the Enterprise Plus version of vSphere in your licensing. And so your use case for using a standard switch is, do you have Enterprise Plus or do you not? Then down in the interaction portion, we spent some time talking about creating a standard switch. We created a couple. We configured some of the vNICs. We configured those VM kernel ports so that we could segregate out the network services. And then we also configured a couple of port groups, one for our standard server net and one for our DMZ net on that host ESXi1. Coming up next, we're going to talk about vSphere distributed switches. And as you probably realized, all the configurations that we've done here are very specifically focused on one host. Everything we've done here only configures that networking for that host ESXi1. And that's going to be fine when I have a couple of hosts. But when the number of hosts that I have to manage gets very large, making sure that that networking configuration is exactly the same across all those hosts can be a little bit unwieldy. It is for that reason why distributed switches exist. Distributed switches exist as a way to, via a policy approach, apply switch configurations to a large number of switches all at once. You can kind of think of it as group policy for vSphere switches. But that's a topic for our next nugget. So until then, I hope this has been informative for you, and I'd like to thank you for viewing.